All right. This is lesson 623, standard form of linear equations. We're going to learn how to graph equations using the intercepts. That means the x and the y intercept. And we're going to learn how to write linear equations in standard form. The standard form of linear equation looks like this. Some number times x plus some number times y is equal to some number. And a, b, and c are all going to be integers. In other words, we're not going to have any whole numbers, or we're not going to have any fractions or decimals in that. All right, so just to get started here, let's look at a problem that we can use for standard form to represent fairly easily. An athlete wants to make a snack mix of peanuts and cashews that will contain a certain amount of protein. Cashews have 4 grams of protein per ounce. Peanuts have 7 grams of protein per ounce. How many grams of protein will the athlete's mix contain? What do the points 7, 0, and 0, 4 represent? Explain. So, well, the number of grams of protein in this mix we can get from looking at this graph. If we have 7 ounces of cashews, now each of those 7 ounces have 4 grams of protein, so we can just multiply by 4. And according to this graph, if we have 7 ounces of cashews, we're going to have 0 ounces of peanuts. So we would have 7 times 4 plus 0 times 7, which is 0, so that's 28 ounces. This point up here represents that we have 4 ounces of peanuts and 0 ounces of cashews. So now we would have 0 times 4 grams of protein from our cashews plus 7 times 4, or 4 times 7 ounces of protein from our peanuts. And that would give us 0 plus 28 equals 28. So any point along the line here, we're going to have 28 grams of protein. And the equation that represents that is 4 times x, which means 4 times the number of ounces cashews, plus 7 times the number of ounces of peanuts is equal to the number of grams of protein that we get in the mix, which is 28. All right, and that's an example of an equation written in standard form. So one thing great about standard form is it's really easy to find the x and the y intercepts. So that's what we're going to do first here, learn how to find those. And remember that the x and the y intercepts, I'll write that here. The x-intercept is a point on the x-axis. And since it's a point on the x-axis, we know that, looking back at the problem we just did, so that's this point right here, 7. We know that the y value there is 0. So that can help us find that point. And likewise, when we're trying to find the y-intercept, which is right here for this problem, there's the y-intercept, the x value is 0 for that point. So to find the y-intercept, to find the x-intercept, we're going to let y equal 0. To find the y-intercept, we're going to let x equal 0. So if we take this equation and we let y equal 0, we're going to just substitute 0 in for y, and 6 times 0 is just 0, and 5x minus 0 is just 5x. And then we need to just divide both sides by 5, and we get x equals 12, and that's our x-intercept. To find the y-intercept, we're going to let x equal 0, so we're going to do 5 times 0. And 5 times 0 is just 0. And 0 minus 6y is just negative 6y. And negative 6y, we're going to divide both sides by negative 6 and find that y is equal to negative 10. So that's how you find the x-intercept and the y-intercept. All right, so go ahead, you try that. You can check back here with your answers. Pause right now. So finding the x and y intercepts, go ahead. All you do is substitute 0 for x to find the y-intercept, and substitute 0 for y to find the x-intercept. So if I want to find the x-intercept, we're going to substitute 0 for y, and we get this, 2x plus 6 times 0 is equal to 18. And 6 times 0 is just 0, so we get 2x equals 18, and we can just do 18 divided by 2 to get x, which is 9. To find the y-intercept, we're going to substitute 0 for x, and in that case we're going to do 2 times 0 plus 6 times y is equal to 18. And again, 2 times 0 is just 0, and 0 plus 6y is just 6y. And then we're going to divide by 3, and we get y is equal to, divide both sides by 6, and we get y is equal to 3. All right, now what's really nice about this form is graphing. So because you really only need 2 points to graph a line, so, and it's easy to find the 2 intercepts. So first let's get the x-intercept here. So that's the point on the x-axis. To do that, we're going to let y equal 0. And so we're going to do 4 times x minus 3 times 0 is equal to 12. Well, 3 times 0 is just 0, and 4x minus 0 is just 4x. And then I'm just going to do 12 divided by 4 to find x, which is 3. And so I'm going to put that point on my graph right there. X is equal to 3. Then to find the y-intercept, I'm going to let x equal 0. So I'm going to do 4 times 0 minus 3 times y equals 12. Careful here with the negative sign. 4 times 0 is 0, but 0 minus 3y is negative 3y. Divide both sides by negative 3, and we get y is equal to negative 4. That's my y-intercept right there, negative 4. But then we have 2 points. We can make a graph by connecting those 2 lines. And that's all there is to it. All right, so here, go ahead, you try it. I'm going to pause here and see if you can do it, and you can check back with your answers. You should get a line that looks like that. All right, graphing horizontal and vertical lines. If the equation says that x is equal to -1, that means that the x-intercept is -1. And it also means that every other point, and I can just make a quick table here, every other point on that line, the x value is equal to 1. You can't change that, -1. So when y is 0, x is -1. When y is 1, x is -1. When y is 2, x is -1. X is always -1. And if I graph those points, I get points like this. So we can see the pattern here. Remember, x has to be -1, so the value on the x-axis always has to be -1 for all these points. And so that graph is just a straight vertical line that goes through the point -1 on the x-axis. Now likewise, we get a similar story here when y is equal to 4. So no matter what my x value, y has to be 4. And I can pick random points or whatever. But so if I graph these points like 0, 4, 1, 4, -3, 4, and so on, you can see that all of these points are lining up right along this line. And so that graph is y equals 4. And this graph was x equals -1. All right. All right, transforming to standard form. This equation is written in slope-intercept form. To put it in standard form, we need it to look like this. We need x and y to be on the same side of the equal sign. And we need some constant on the other side. The other thing we need are all of these values to be integers. So to get that, I'm going to start by getting rid of this fraction. So I want to think of a number, something I can do to both sides of the equation that will get rid of that fraction. And since that fraction is dividing by 5, if I multiply by 5, that will eliminate that denominator of 5. So first thing I'm going to do is multiply both sides by 5. So I'm going to multiply 5 times y, and I'm going to multiply 5 times negative 3/5 x plus 4. And when I do that, I'm going to get, using the distributive property, 5 times negative 3/5, and you can use a calculator if you want to get that, but that's equal to negative 3x. And then I have to distribute the 5 and 4, and that's equal to 20. And now all I need to be in standard form is I need this 3x to be over there with the y, and I'm going to get that by adding 3x to both sides. And then I get this 3x plus 5y is equal to 20. All right? Go ahead, you try it with this. Actually, I'll work through this one with you. Circle the first step to put it in standard form. I think I'm going to start by multiplying both sides by negative 3. What that would do is get rid of that 1/3, and we can't have any fractions when we have it in standard form. So I'm going to multiply both sides by negative 3. So I'm going to use parentheses to show that I'm multiplying the quantity y minus 2 times negative 3. And I'm also multiplying this by negative 3. And when I do that, I'm going to use a distributive property here. Plus 6 is equal to 3 times, negative 3 times negative 1/3 is equal to positive 1. When I distribute that 1, I get 1x plus 6. And then all I have to do is, to be in standard form, I need to get this 6 away from the side with the y. And then I get this. So we subtracted 6 from both sides. And now I just need to subtract x from both sides to get rid of that. Now, when you subtract x, you actually have negative 1x. And then since it's 3y, we have minus 3y is equal to 0. Now it's in standard form. The coefficient of the x term is actually negative 1, but you don't have to put that. You could also, if you did this before me, another equivalent form of that equation would be x plus 3y is equal to 0. So we can write it either way, negative 1x plus negative 3y, or we could just write x plus 3y equals 0. All right, last thing we're going to do is learn how to write equations. Festival sells ride tickets for 50 cents each and game tickets for 20 cents each. You have $5 to spend on tickets at the festival. Write and graph an equation that describes the items you can purchase. What are 3 combinations of game and ride tickets you can purchase? So let's let x be our number of game tickets and y be our number of ride tickets. Okay? And if we think of this, an expression for how much we spend on game tickets is, actually I think I'll change that. Let's let x be our ride tickets and y be our game tickets. So we'll just switch those around. If they're in that order in the problem. All right, so if I multiply 50 cents times my number of ride tickets I want, that expression represents how much I'm spending on ride tickets. And if I multiply 20 cents times the number of game tickets I buy, which is y, that represents how much I spent on game tickets. If I add those, that's the total I spent. And since we have $5 to spend, we know that those two add up to $5. Now, the only thing I might want to do to fix up this equation is to be in complete standard form, I might multiply everything by 100, and that would get rid of the decimals. But I think for this problem, we can just use what we have here. And so some possibilities of what we could do, let's say we have 0 ride tickets. Then the number of game tickets is just $5 divided by 20, which is 25. If we have 0 game tickets, then we can spend all $5 on ride tickets, which would allow us to buy 10 of those. And some other combination, let's say we buy 5 ride tickets. Well, that's going to take $2.50. That one won't come out even. Let's say we buy 5 game tickets. 5 times 20 cents is $1. And then got to subtract that from our $5 total. That would give us $4 to spend on ride tickets. So that will give us 8 ride tickets. And those are just some possible combinations. That's going to be it for this lesson. We'll do the rest in class. See you tomorrow.